So Jiva, next we're going to talk about variables.
Right. So the next thing to talk about is variables, and what is a variable? So variables are places to store data in your Obj-C programs. So you can store all kinds of things like integers and characters and strings and objects and things like that. Interestingly enough, the code that we've already been looking at, the project that we got from the template, actually already has a couple of variables that are passed to the main function. So if we take a look at that, you'll see actually that we have this code here where it's creating this argc and argv. Both of these are actually variables, and they're passed into the program, and those are available within the scope of your main function. We'll talk about scope here in just a second. We'll talk about what each of these declarations mean, and the type and the variable name and things like that. But just to sort of give you an idea of how a variable works, the argc that you see there is used to store the argument count for your program, and the argv is each of the actual arguments that are passed to your program. So for example, we can take this variable, this argc, and we can change this code here so that we take out the hello world, and we can say the number of arguments passed to this program is, and then we can do this %LD. Now this is actually a format string, and I hate to keep saying this, we'll talk about that later, but that's something else that we'll talk in more detail about later. But we're going to do that, and then we're going to say comma argc. And if we do that just like that, then what we're actually going to do is we're going to use that argc variable, and we're going to print out the contents of that argc variable. So if we run that, if we build that program and then run it, then the actual output of that program will show the number of arguments passed to this program as 1. So as you can see there, in this particular case, the 1 indicates the actual name of the program. So that's actually what was stored in that variable is 1 for that particular.
Right. So whenever we run a console, a command line application, there's always this perceived first argument, which is the name of the program.
Right. Exactly. So next, I'm going to show you another program where we actually declare a variable. So if we jump over to that source code and take a look at that. Now in this particular case, so you don't just have to work with the variables that are just passed to your program, you can also create your own variables. So in this particular case, we're actually creating this variable called a variable, and we're storing in it the value 5555. And if I run this program, same kind of thing here, I've got this nslog statement here that does the %LD, and it takes that variable and it'll print out the contents of that variable. So if I run that program, then it should actually print out 5555, just like we printed out 1 before.
Okay.
So as you can see, that's exactly what we get. So I guess, you can look at this and you say, okay, so what are we doing here? What does it mean to declare a variable? So just like up here in our main function, we declare a variable by specifying first its type. Okay, that's what this int is here. We're declaring a variable to be of type int, which is an integer.
Okay.
Then we specify the name of that variable. In this particular case, it's called a variable. Now the name can be anything you want. Again, that's another one of those things that programmers tend to argue about, is what's good naming conventions. But the important thing is that it has to be meaningful for you. You should always try to write your code so that strangers reading it 6 months from now will know what you meant. Right. And the important thing to remember is everyone's a stranger 6 months from now, including yourself.
So variable names like A, B,
useless.
C
yeah.
are not particularly useful.
Exactly. Even variable names like a variable are kind of pointless. But, so if I was writing something, I want to name it something that was meaningful, whether it's, argument for such and such function, or, gold amount or something like that.
So we might name that one integer to display.
Exactly. Yeah. In fact, we could do that right now. Integer to display. Now we'd have to also change it down here. And as you can see, Xcode gives us the code completion for that. So just making that change actually doesn't change the functionality of the program. It's just making it more readable for us. So that's the variable name. Now, so once you've created the variable, then you can store things into it by using the equals operator, which is exactly what we're doing here. So, for example, we create this integer called integer to display, and we set it equal to 5555. We're taking that that value of 5555 and storing it into the variable integer to display. Then we can reuse that variable in the NSLog statement to print that out. Pretty cool stuff.
Now, can we change that variable at any point, or is it stuck at what it's initially set to?
You can reassign, you can change the contents of that variable to anything that you want, assuming it's not a constant. So there is a special keyword for constant variables called const, which will allow you to specify that a variable's value cannot be changed. So in that case, if you try to change its value, you'll get a compile error. But if it's not a constant variable, then you can actually set it to anything you want.
Okay.
Now, the next thing to understand about declaring variables is in thinking about the lifetime of a variable. Where does a variable exist? Where can I use it? What are the rules associated with that? And all of that kind of relates to a concept called scope.
Okay.
Okay. We talked a little bit about the curly braces in the previous segment and about how that defines the scope of the main function. And really, that also defines the scope of any variables that are declared within those curly braces. So, for example, if we go over and we take a look at this project here, we've got several different variables that are declared in this project. The first one here is this a variable 1, okay, and this is specified to have a value of 5. Now, this one is actually declared in the scope of the main function itself. So its lifetime will exist from this first, well, it will actually exist from its declaration until the terminating curly brace of the main function.
Okay.
Now, inside of this main function here, we have another set of curly braces. And this is actually defining another scope within the main function itself.
So we can just declare new scopes by putting curly braces in.
Exactly. You could actually put curly braces anywhere you want, and it'll create new scopes there. Now, typically people don't usually do this when they're writing programs. Typically, you would have something like, if such and such here, equals foo, whatever, to only execute the code within the curly braces if that condition is met. But here we're just talking about scope. So I don't want to confuse us with talking about conditionals and things like that right now. So the important thing is to know that the curly braces indicate scope. Now, another word for scope also is the stack frame. This is something that's used in programming books and in programming concepts, is the stack frame. So the scope is also known as the stack frame. And as you work through your program, as you call other functions and you move into their scope, it's known as moving into their stack.
Okay.
So this variable here, this int a variable 1, is said to be declared on the stack and to have the scope local scope inside this main function.
Right.
Now, this variable here, this a variable 2, is also declared on the stack, and it is in the second stack frame inside of this inner scope, and it only exists from where it's declared there until this ending curly brace right here.
Right.
Okay, because it's declared inside of this stack right here.
Right.
So, for example, if I wanted to access a variable 1, it should be noted that a variable 1 here, which was declared out here, still exists inside of this scope. So you have this sort of nesting thing that goes on. A scope that's declared inside of another scope includes all of the local variables that were in the parent scope as well.
Right, okay.
Right? So a variable 1, which was declared out here on the main scope, is also available inside this secondary scope. So both of these are okay. However, because a variable 2 goes out of scope at this curly brace right here, if we try to access a variable 2 down here, we'll actually get a compiler error.
Okay.
Because it doesn't exist at this point.
Right, so it only exists in its scope.
Exactly. Now so we have this scoping inside of functions and inside of stack frames is known as local scope. So all of these variables are local. That is, they're only available inside of that stack. There's also global scope. So if I came up here, for example, and I declared another variable up here, int a variable 3, that variable has what's called global scope. So that's actually available throughout my application everywhere.
That's because it's declared outside of anything that's defining scope.
Exactly. Now, global variables are kind of...
bad, I think, is the word you're after.
Maybe bad would be the right word to use. They're like a sharp tool. You want to use them only when you really need to. It's not. They quickly can lead to spaghetti code and code with sort of unusual side effects. Because if you're relying on a variable that was set over in this function over there to be some value, and you need it over here, sometimes you don't always know the conditions that are required to use a particular variable. So generally speaking, try to avoid global variables if you can.
I mean, we're not saying never ever use global variables, but I would say if your instinct is, oh, I need a global variable because I need to do this or do that, probably there is a better way you just haven't learned yet.
Yes, exactly. Now, so we talked about global variables, we talked about local variables. That has to do with the scope of the variables. There's actually a couple of other terms that you'll sometimes hear related to variables, and that is member variables and instance variables.
Right.
Now, these are actually object-oriented terms, and we'll really talk a lot more about those when we talk about object-oriented programming. But it's useful to kind of familiarize ourselves with the terms here when we're talking about variables. Specifically, member variables are variables that are members of a class. So they're variables that have scope within an object, within a class. And instance variables are variables that store objects. So if I create an instance of a class, an object essentially, then I store it in an instance variable. Now, sometimes there's a lot of programmers who sort of use these terms interchangeably. So, for example, they might refer to member variables as instance variables. And it's kind of one of those things where a member variable or member variables can be instance variables, right? Because they can store objects. And instance variables can be member variables. So you'll hear these things used, interchangeably a lot. I prefer to use the term member variables to specifically refer to variables in classes or in objects, and instance variables when I'm talking about kind of concepts relating to a local scope. So if I'm going to use an instance variable phrase, then I'll be referring to interactions with that variable at a local scope. And when I'm talking about interactions with even that same variable or another variable at a class-wide scope, then I'll refer to it usually as a member variable.
So that's just important that as you're speaking, that's the terminology you're using.
Right.
You accept that others might use other terminology. Neither are wrong, but people need to understand that's what you mean when you talk about this stuff.
Exactly.
Okay.
Now, the last thing to really kind of understand about variables at a high level is that we talked about how a variable is used to store data, right? So in order to store data in it, there's got to be storage associated with that data, with that variable. And there's really sort of two places that memory, well, when you talk about storage, you're talking about memory. And there's really two places that memory can be allocated from. The first is the stack, which is what we've seen so far, right? Each of these variables that we've seen so far have been what's called allocated on the stack, which means that they have their memory is stored just within the scope of the thing that we're working with right here. The other kind of memory that can be allocated for a variable is called on the heap. And the heap actually refers to sort of this general pool of memory that you can say, I need a chunk of memory of this size. And you, by doing that, you have this memory available to you, and you keep that memory until you no longer need it. So to sort of differentiate between the variables that I've shown so far and that, rather than that variable disappearing when it goes out of scope, you may not necessarily be able to access it anymore, but that memory will stay allocated. So now, typically, you wouldn't want that kind of a situation where the memory is still allocated, but you can't access it anymore. But it's an important concept to sort of understand because it explains a lot about memory management, which we will spend a lot of time on in the future. But the important thing here is to know that there's these two different kinds of memory that you can allocate from, stack and heap. Now, generally speaking, variables that are stored on the heap will be declared to be a special kind of variable called a pointer. Now, pointers are a C concept. They come from C, and they're kind of a complicated thing to get your head around. All of the variables that we see here in this particular program, right? These are all just declared variables. So if I have this a variable 1, it's right there, and I can stuff things into it and stuff like that, right? But if I wanted to create a pointer to this variable, what I'm actually going to do is I'm actually going to say my memory is out there on the heap, and I'm going to allocate that memory, and then I need something to tell me where that memory is.
Right.
And that's what a pointer is. So if I wanted to change one of these variables, or if I wanted to declare a variable that was a pointer, then I would just do something like, let's call it a foo type. We'll talk more about why we want to use something kind of like that later when we talk about objects. But let's say it's a foo object, and then I would use the asterisk operator and then the name, a variable 5 or something, right? And then I would create that variable using either using something like malloc or I would create an object to store in there. So that a variable 5, because it's a pointer, is indicating that, again, the memory for this is allocated on the heap, and this pointer just provides me a pointer to that memory. So I can access it, I can hit that pointer, and I can go access that memory out on the heap. The important thing to know about that is, again, going back to that, the fact that that memory will stick around until you dispose of it. So you want to make sure that you not just allocate that memory, but also free it. And we'll talk about how we do that when we talk about memory management.
So let me make sure I understand this. What we're saying there is when we start dealing with memory or variables that are on the heap, is we actually need to access that memory somehow. So we're using a pointer. The pointer is actually a variable declared on the stack. But just like all the other ones we've seen so far, that variable will go out of scope at some point based on where it is in its scope declarations, and as soon as that goes out of scope, we have no longer any way of reaching our memory that's on the heap.
Right.
But the memory on the heap won't go away until we tell it to go away.
Right.
That's there. Scope has nothing to do with that. That stays there forever. So we have to get used to, as we go through later on with our concept of variables, of making sure we manage this memory out on the heap. In other words, make sure it goes away when we've finished with it, because it's not going to automatically do it like our variables on the stack do.
Precisely. Now, the good news is, so pointers are a kind of a weird thing to know about and to think about, especially in C. There's all kinds of interesting things that you can do with pointers and things like that. But the thing is, they probably cause more headaches for computer science majors than just about any other programming concept in C. Fortunately, in Objective-C, 99% of the things that make C pointers a pain you almost never deal with in Objective-C. Really, you're only going to deal with pointers for the purposes of storing objects. and you don't even really need to think of it as a pointer. You can just say, if I see an asterisk with a variable name, I know that it's an object, 99% of the time.
So the people who were beginning to run away,
they can come back.
They can come back.
Yes.
Okay, so I mean, that's been we're going to look at pointers in more depth, and we're going to look at memory management more depth. Please don't think you've got to understand it from what's been said so far. But I guess now we have this understanding of variables and declaring them. When we come back, it'd be good to sort of look at the different types of variables we can have.
Yep, exactly.
Okay, so that's what we'll do when we come back.